Okay, so I guess this is a third video using this noname project as an education or as a way to like teach how programs can get compiled into Git for zero knowledge proof systems. I have just written the function feature, which is that you can actually implement your own functions in addition to the main function. You could only write a main function before, and no, I believe this works. I just run it and it says that the proof was created and the proof was verified. I have no idea if it's actually correct. I'm gonna use the debug output as usual, as I've done in the previous videos, to check if it's correct. And I guess we're gonna do that together, and if I find a bug, then we'll find a bug together. So yeah, let me copy that and I'll put that on the right so we can read that in a easier way. And from the get-go, we have the public input, which uses double generic gate that sets the left input, the very left input, the first input, as the public input. So we've already seen that in the first video, so I'm not gonna go over that. Here, ooh, that's weird. That's weird. So, okay, maybe I guess. So this feature of like showing you the line is like using like a span thing. A span is pretty much you can look at the book. There's a book of noname that explains that. I'm just gonna show you the markdown version, but it pretty much explains what a span is. It's just a usize and a usize, and the first one tells you where you are in the source code, and the second one tells you how long it is. So how long it is this thing here. And so I use spans all over the place to sort of like tell you when you create a gate, what exactly created the gate. But sometimes I have some bugs and it's not necessarily the most intuitive span. So if we go back to our program here, you create 4 from adding 1 to 3, which is really going to call add and do this thing. And so probably that's the first constraint it's creating. It's this thing, which is kind of weird because shouldn't constrain 3 first before doing this thing? In any case, it would have been nice if it would have shown both, like both this line, the add, because this is the one triggering the add function, and this line as well, because maybe you're calling the add function several times and you want to know for sure that is this one call of the add function. I guess this is what you call a backtrace, and it would be kind of annoying to see the backtrace here. If I would do that in HTML, maybe it would be fine because you could like kind of hide things and you can open it up. Maybe I should do that in JavaScript. It'd be nice, but yeah, for now I only add one span. I don't have real backtraces, and so this addition here it's not clear that it comes from here, but it does. Anyway, hopefully that makes sense. Okay, let's analyze what's going on here. Add a constant with a variable. Okay, so it knows that it's a constant. It doesn't encode the value 3 and then wire it to that addition. It actually just uses the constant coefficient of that generic gate. So maybe I'll write right here. If you don't remember, it's like first number times left input plus second number times right input plus third number times the output plus fourth number times the left the right, this if you want to do multiplication, and then the constant equal to 0. And so if I want to do x plus y, which is really x plus 3 in my case, because this is a constant, right? So y is a constant. I can basically write that as so here the left input was set to 1, so it's like C0 is 1, C1 here is 0, so this is 1 times left plus 0, so I'm not going to write it. We have a minus 1 here, so it's minus 1 times O plus no multiplication, and then C4 is set to 3, so this is really a value set at compile time, plus 3 equals 0, right? And this is equivalent to L plus 3 equals output. The left input plus 3 equal the outputs, which is exactly what we wanted to do here. So this is correct. Of course, we need some wiring. Let me do what I did in the previous video. Ooh, maybe that's too much. Okay, maybe that's enough. We'll see. And I'm gonna put the wiring next to it. The wiring is here. So I just want to make sure that the one here is wired to this addition, right? So get 0 to get 1, get 0, position 0, the left input. Get 1, position 0, which is here, the left input. So this is correct. This is nicer. Okay, so we go here, we have the addition, 4 is here, and then we assert that 4 is equal to 4. So as usual, we're going to see, I guess I always make a mistake. I always think it's going to encode that value in the circuit, but actually, oh no, it does, okay. So it encodes a constant, right, in gate number 2, and then it does the assert. Oh yeah, because it's not, I guess it's not super efficient. We could have just done, it should have done, you know, I think we can do an optimization here where we just add the left input to a constant -4 and just check if it's 0. Because basically here, when we're checking if this free variable is equals to 4, when we encode the constant, we could have not have that as a free variable, but have that as a wire to the result of that addition here. So there's really something we can do here. There's really an optimization, and I guess I could do it in front of you. I don't know if it's a waste of time to do it now. Let me check if it's easy. So field has, oh no, the built-in is an assert, right? So where are the built-ins? In stdlib, there are the built-in functions somewhere. Where is it? No, these are crypto functions, and okay, so we have the assert and assert equal. These are the signatures. This is the code base. You don't really have to know about the internals, but maybe it's interesting. And here we're using assert equal. And assert equal basically look at the left hand side and right hand side, and it checks, are these two constants? If these are two constants, I can just check in real time. We don't need to enforce anything. If we have one const and one cell, so like a real variable and one constant, then we can, this is what's happening. Constrain the constant first, so it calls constrain on the constant, which will create that that encoding the constant thing, right? I'm actually writing that here, and we'll create that generate gates. So if I click here, you can see it calls compiler at constant, iterating direction, and it adds a gate here, and then it adds a gate here with the constant variable that we just created. But I think we can do better. We can just let's do this. We're gonna put. I'm gonna add it here actually, so you can see exactly how I do it. I'm gonna do var minus constant, and I'm gonna put the var here, and I'm not gonna put the constants in the variable. So this vector is just variables. This is the type of the gate, and this is the comments that you see appearing here. And then we can set the coefficients. So this is like how you tweak your gate, and this is the span for debugging. So the gates, we're tweaking it here. The left input is on. The right input is going to be 0. And actually, I think I don't need to write. Okay, I don't have this on. Never mind. It's going to be 0. The output is still going to be 0. The multiplication is going to be 0. And then the constant is going to be negative the constant that we pass. Where's the CST? So Can I do CST neg? I'm not sure. What is CST? So constants. What's in the constants? There's the value here, so we're gonna get the value, and we're going to negate that. And I'm going fast because I know you can pause the video. And no, we don't need to have these gates. We don't need to constrain the constant first. We can just have one gate. So we're gonna see if it works. Ooh. Looks like it worked, and no, we only have actually 3 gates, right? 3 gates instead of 4. So and only 2 wires, two wires instead of 3. So okay, that's not bad. That's not a bad. Okay, so let me copy this, and we're gonna start analyzing from scratch. And like I'm saying, I'll delete a bunch of stuff so that it's more readable. And what am I doing? What am I doing? The wrong direction. Okay, that's nice. So let's look at the gates and let's look at the wiring here. And let's put back these functions file. Okay, so we're back here. The add is, oh, sorry, the public input is still the same thing, right? We're not changing anything. I don't know why this is broken. So we know we're not encoding. Oh, sorry, the addition is still the same, right? The constant is passed here. So we do 1 plus 3. So still the same, nothing has changed, and the wiring is still wiring 1 to this place in the addition, hasn't changed. And now we assert that the result of that addition, 4, is equal to 4, right? And now we only have one gate to do that. Beautiful. It's actually checking that the constant here is -4, so what's here, -4 equals 0. That's what it's checking. And we just need to make sure that 4 is actually wired. So 4 is the result of gate 1, is wired to the left input of gate 2. Left input of gate 2 is wired to the output of gate 1. Okay? And that's it. That's it. We're done. So we have a bug, right? 8 is not calling double. Interesting. So I guess I'm gonna have to figure that out. Did I? No, that's it now. So I guess there's a real bug here, and I'm wondering why there would be a bug. I'll just check. Yeah. Okay. Interesting. So I'm going to pause the video now and investigate why I have a bug.